Hello guys, today we are going to discuss industrial packing machine implementation using PLC and pneumatics. So it is going to be part 1 and part 2 because this is going to be little bigger video size. So I am going to split into two parts so that it will be easy to understand as well as easy to follow up. So first part I will discuss about the structure of this application, sensors, solenoids and actuators involved in this. Mostly we will focus much on the electro-pneumatic part, and in the second video we will convert this electro-pneumatic part into the PLC controlled pneumatic part, so that we will see step by step, so it will be easy for understanding. So first let us see the structure of this machine. So where we are going to see the different actuators and valves, sensors and conveyors, like that. So this structure has two conveyors. The first conveyor is the one which is going to bring the objects from a place from where it is being produced or assembled, and then we are going to have a sensor to count this number of objects which is crossing this particular location. And this sensors, once it is reached to the conveyor end and the required number is achieved, the counter which is counting this the number of objects will give the signal to the stopper cylinder, so that the stopper cylinder will uh, give the forward motion. The cylinder will actuate and it will give a forward motion so that it will stop this objects further. But the conveyor, still it is a rolling conveyor, it will just keep rolling and the stopper cylinder will stop the object. And we are going to have the second conveyor which is going to have a ray or a bin where you are going to keep these objects inside, and you are going to pack it and it will move further to the further process. Okay, so this conveyor also will be controlled by using a sensors, which is going to be a level sensors or position sensors. So based on the position sensors, it is going to move inch by inch, so that the objects will be placed in appropriate places, like palleting. Okay, and apart from this we are going to have cylinders and actuators, where we have one rodless linear unit. So this will be the rodless linear unit, which is colored as a green color one, and which will move horizontally from x to x minus, or whatever it is. And then the yellow color one is a lifting cylinder, or the cylinder which is used to go vertically up and down. And we have a semi-rotary actuator here, so which is going to rotate the object once it is picked from the conveyor 1, which is going to rotate 90 degrees or 180 degrees as per the requirement. And then it is going to, when it is coming back, the rodless linear unit comes back to the home position, so it is going to keep it down. And we are also going to have a suction cup which is going to carry the objects using the suction principle. So this is the total description of this particular circuit or the assembly. Okay, so in this we will see what are the number of sensors and where we are going to place these sensors, and then how the solenoids is going to get actuated using the sequence. So these are the sensors I just mentioned here few. The limit switch LS1 used to count the object and the stopper and stop the conveyor 1. So this is what I said, the number of say object when it is passing through this LS1, it will make a count using a counter, and then the counter will decide when the stopper cylinder should come forward and stop the objects further coming there. And the second set of sensors will be placed, LS2 and LS10 will be placed in home position and extended position of the stopper cylinder. In this is the stopper cylinder. One sensor LS2 will be in home position and one will be in the extended position. So mostly it will be a magnetic sensors which will be on the cylinder itself, so that it can detect the home position and extended position. So for this stopper cylinder, and similarly we are having a LS3 and LS4 which will be placed in the rodless linear unit, so for home position and extended position respectively. And LS5 and LS6 are placed in lifting slide unit, so which is going to be a vertical movement. So again these sensors are going to be in home position and extended position respectively. and limit switch LS7 and LS7 placed in semi-rotary drive home positions and extended position respectively. And then we are going to have LS9 to control the conveyor. So this LS9 we are going to have actually 4 sensors. I just mentioned here one. So in the upcoming slides I can differentiate this. So we are going to have 4 different sensors for doing this work. Okay, so these are the sensors, and the solenoids 5 by 2 double operated DC valve for controlling stopper cylinder. So this is one solenoid valve, and 5 by 2 double solenoid operated DC valve for controlling the rodless linear unit, and similarly for lifting slide and semi-rotary drive, and also for the suction cup. So we are going to have all memory valves. So when we are understanding the concept of the concept for programming, so it is very important. So because we are not going to use any latching because of this 5 by 2 double solenoid operated DC valve, since once you give the signal, even the signal is not there, it will keep that position in the same position because of this memory capacity. So relay 1 and 2 used for controlling the conveyor, and the cylinders we are going to have actually I mentioned here single acting spring return cylinder, but it is also a double acting cylinder, since we are going to have 5 by 2 double solenoid operated DC valve. So we are going to have double acting cylinder here as well, and rodless linear unit, lifting slide, semi-rotary drive, suction cup, conveyor motor 1 and 2. So these are the actuators, solenoid relays and sensors which is going to be used in this assembly. Process sequence for understanding this, first we need to understand bit about this total function of this particular application. So let us assume first actually this particular lifting unit, the resting position or the home position will be here. Okay, so this is my home position. So from here only we are going to start the total process. Okay, so first what it has to happen, so all these objects, okay, so the number of objects is say 10 or 5 or 6. Here in this example it is 4. So here we are going to place a sensor. Say for example here LS1 will be placed here. So whenever the sensor is sensing the object and the required count is reached, so that means say here for this example 4, the count 4 is reached, then the stopper cylinder will make the cylinder to forwardly move, so that the piston will come forward and it will stop the further movement of this object. So this is the first action. So once this is extended, then that means the lifting slide unit and the rodless unit, the total unit has to move from here to this side. Okay, say for example x to x minus, so it moves from this direction to here. So for once it is reached to this required position, so here the extended position, then the lifting slide will go down like this, go down, and once it is reached to this down position or the extended position, then the suction cup has to given signal and it has to take the object. Once this is done, then the semi-rotary actuator has to rotate in this direction, and same time the rodless lifting unit has to go up. So this action takes place simultaneously. So that is suction cup taking the object, and then semi-rotary unit rotates in a anti-clockwise, and also the lifting slide or the lifting cylinder lifts the object. So all three of them are taking place at the same time. Once it is coming to this home position of this lifting slide, then again your rodless linear unit has to come back to this home position. So once the rodless linear unit is reached to the home position, then again from here it has to go down. Okay, from here it has to go down, and once it is reached to the extended position of this condition, then it has to release the object. Okay, using the suction cup has to release the object. Once it is placed in this required slot, then the semi-rotary actuator will turn back clockwise. So it rotated in anti-clockwise, now it will turn back to clockwise, so go to the home position, and the lifting cylinder has to come back to the home position, so and it will stay in this position. So this is a one cycle or one full cycle of or operation of the application. So after completing this task, again the this conveyor, that is second conveyor, will move further. So this object will go here, so that the vacant place will come near to the home position of this total unit. And again the same process takes place, going to this left side, and then going down, picking the object, coming up, and then coming to the right and going down and placing the object in the pallet or in the box. So this is the process. So for sequence, as I told you, this is what in sequence: limit switch operated counter stops the conveyor one and extend the stopper cylinder. So this is my first step. So for doing this work, I am going to make sure the counter reaches the count, required count, say 5, 6 or 4, whatever it is, and all my cylinders are in home positions, that is rodless linear unit and lifting slide, and then my semi-rotary actuator, all the actuators are going to be in home position. So this I make sure. So once this all conditions satisfies, that means the stopper cylinder will move further. And once the stopper cylinder reaches to extended position, that is extended position will be detected by LS10. So this LS10, once it is reached, so again I ensure that all these actuators are in home position, and only the the stopper cylinder is extended to the extended position. So once these two conditions are satisfied, then the rodless linear unit will move to the left side. And once it is reaching to the left side, that means it is extended condition, so that means it reaches the LS4. Okay, so the LS4 is reached, and LS5 and LS7 is in a home position. So that is your lifting cylinder and the rotary semi-rotary actuator, both are in home position. Once this condition is satisfied, then it will go down, as well as the gripper solenoid will get the signal. So two things are happening here. One is lifting slide going down, and also the gripper solenoid is getting the signal, so that it is ready to grip the object. So when it is going down, same time the gripper cylinder also is getting the signal, so that the gripper is getting on. So that means once the forward motion of this lifting slide is reached, so LS6 will be get actuated. So once this LS6 is actuated, LS4, so that is the rodless linear unit is in the extended position, and LS6, that is the lifting cylinder is in extended position, and the semi-rotary actuator is in home position. So all these conditions are satisfied, then it will give the signal for taking the object, as well as to come up. So the cylinder, the lifting cylinder will go up now. So once this is done, so limit switch LS5, what happens actually when it is going up, same time the semi-rotary actuator will move anti-clockwise direction. So once it is moving anti-clockwise direction, it will reach the LS5 position, and the limit switch yes, so the LS5 is the home position of the this one, and as well as LS8 is the semi-rotary actuators, this extended position or the rotated position. So here, so these two conditions, when it is reached, so that means the object is picked and it is in the this position. So it has to move back to the right side direction, and once it is reached here, it has to go down like this. So with this two condition, LS5 and LS8, so it is going to give the signal to move from left to right side direction. And once it is reaching to LS3, that is the home position of the rodless linear unit, and LS8 is your semi-rotary actuator extended position. So when these two conditions are there, so that means the lifting cylinder has to go down again here. So the lifting slide has to two times go down. One is from here, that is extended position, and here in the home position also it has to go down. So for making that, LS3 and LS8 should be there, so that it goes down here. Okay, so once it is going down, then it is going to once it is reached to this extended position of this extended condition, sorry, in the home position of the rodless linear unit, and the lifting slide is in the extended position, and the LS8 is in this condition. So when this all conditions are satisfied, so it is going to drop the object. So the limit switch LS6 and limit switch LS8. So the LS6 is the external portion of this cylinder, and LS8 gives the signal to solenoid move the lifting slide up and the gripper to release. So rotary drive rotate back, the stopper cylinder to retract, and conveyor to move forward. So all this happens at this position. Okay, so when it is reaching to this position, so this is what happens. The gripper is releasing the object, semi-rotary actuator has to rotate back to the home position, and the stopper cylinder will go back so that it will allow the further objects to come to the next count, and the conveyor to moves inches. Actually it is an inching process. It goes further a little bit and then it stops there, so that it will have the next slot to be filled in that box. Okay, so this is what happens in the sequence. So this is the process sequence. So you can see this is an electro-pneumatic circuit. So where the upper part is our actuator part, the control valve, and then actuator part. So which is a pure pneumatic part. So until this, and the bottom one is a electrical control part. So you can say this is a power circuit and this is our control circuit. So where we are going to have sensors which is going to, so this is my LS1. So this LS1 is going to sense the object. So number of object, if it is reached to the required level, so the counter is going to give the signal here. So this counter is going to make the, the relay to stop, as well as here the counter is going to give the signal for the solenoid of the single acting cylinder or double acting cylinder to go forward. And then here we are going to have S2. So this S2 is a solenoid for forward motion of this rodless linear unit, and these conditions has to be satisfied as we discussed a little earlier. LS10 is your extended position of this stopper cylinder, LS3, LS5, LS7. So the LS3, this is home position of this cylinder, LS5 is the home position of this cylinder, and LS7 is the home position of the semi-rotary actuator. All these three conditions are satisfied, and the counter reaches to this one. So the counter gives the signal for the stopper cylinder in the extend position. So that is LS10. So all these happens, then only the solenoid here will get signal. So once this solenoid is getting signal, so this rodless linear unit moves forward like this. So once it is moved forward, so it is reaching to LS4. So this LS4 is given here. So LS4 and LS5, LS7. So these two are in home position. So LS4, LS5, LS7. So all these three are in this condition. So only this line. Okay. So this line. So this line I will discuss little later. So these three conditions satisfied, then S4 will get actuated. S4 is the forward solenoid for this lifting slide. So S4, when it is giving signal, so the lifting slide has to go down like this. So once it is moving this direction, then you will get a condition here. So where LS6, that is when it is coming to this position, so LS6, and then LS4, so it is also in extended position LS4, and then you will have LS7. So all these three conditions are satisfied, then LS5, solenoid 5 will get signal. And same time you can see LS6, LS4, LS7, same signals are given here, so that S6 also getting signal. So that is semi-rotary actuator, so which is going to rotate in the anti-clockwise direction. So before doing these two operations, same time here you can see this LS4, LS5, LS7. So this line which is going to give signal for S8, so that is your suction cup to be on. So when I am explaining the this one process, I told you when the lifting cylinder is going down, same time the suction cup is also getting on. So this line is for S4 is for lifting slide to go down, as well as the suction cup of forward is S8. So this one as well as S8. So these two is getting signal same time, so that when it is going down, it is ready to pick the object. So once it is reached to LS6, so that is here the lifting cylinder is extended. So then it has to go back. So already suction cup is on. So once it is reached to the extended position, so that means the object will be picked by the grippers. So it has to go up. So that's why when it is reaching to LS6, so it is giving signal for S5. So here S5. So that means the cylinder now it is going up. The lifting cylinder is going up. So once it is going up, then it will reach to LS5. Yes. So once it is reached to LS5, then the lifting slide return has to takes place. So here. So LS5 it is reached. So that means it will give signal for S3. So it means it has to come back to, so that is here when it is moving to, as per our picture, it is moving from right to left. Now it will come from left to right. So initially it will move this direction and in the opposite direction. So LS5 and LS8. LS8 is a semi-rotary actuators, the extended position. So when these two conditions are there, it will come back to the home position of the rodless linear unit. So once it is reached to home position of the rodless linear unit, so that means LS3 will be getting actuated. It has to go down again. Okay, so you can see LS3 is getting that is the rodless linear unit comes back to the home position. LS8 semi-rotary actuator is in the rotated positions, the extended position, and LS6 is a lifting slide extended position. So when these conditions are there, it has to go down again. So once it is going down, okay, so when it is S5 is getting actuated, so this is for retraction, and extension of this is happening here. LS3 is getting actuated, LS8 semi-rotary actuator is in actuated condition, LS5 that is a lifting slide is in home position. So all these are there in the condition, so that it will go down here again. So once it is gone down, and here it will come back. So these conditions. So when it is coming back,
When the cylinder is coming back, same time the gripper has to release and the semi-rotary actuator has to return back to its home position. So for doing this work, LS6, that is extended condition of the lifting cylinder, and LS8, that is semi-rotary actuator extended condition, and LS3, that is home position of rodless linear unit, should be satisfied. So when this condition happens, it has to come back to the normal condition.
so this is how the total process takes place, and you can see the simulation here. So this is only the pneumatic circuit. You can see this is a FluidSim software. So where I have designed the electrical part here, the control circuit, and the actuator part, the main part, power circuit is here. So I am going to simulate it. So it's ready to go now. So this is my LS1. So I am going to make a count. So I have given preset value is 5. So 1, 2, 3, 4, 5. So once it is done, so the stopper cylinder goes up forward, rodless linear unit goes back, and this lifting slide goes forward and coming back. So that means it is object is taking back, and the rodless linear unit is coming back home position, and again lifting cylinder is going down. Then once it is reached, all this lifting unit, semi-rotary actuator, gripper. So this is getting deactivated. The cycle continues like this. You can observe this total process once again. So I have given all the details here in this pneumatic circuit as well. So these flow control valves are used to just to demonstrate that how it is moving, because if you are keeping it directly connected, then that means it will be very fast. You cannot observe anything. So that's I just kept flow control valves to slow down the actuator movement, and maybe in the practical as well, this will be in this way. So that the process takes place in a smooth way. And the values I kept 50%. It may be 50 or 60 or whatever the flow control can be done. So this is a double acting 5x2 valve, solenoid valve, memory valves. So I have used 5 different memory valves here. And this semi-rotary actuator, actually we have to keep a semi-rotary actuator like this. Here it is available. But why I've shown you like this cylinder means I want to show as an automatic one, so that I want to keep this one here in this Yeah, so this is the semi-rotary actuator. This can be placed here instead of this cylinder, but there is no, you know, scale unit here to make it automatic. Okay, so the distance rule is not applicable for the semi-rotary actuator. So here they will keep the sensor in the home position and extend position outside the cylinder, and the remaining units will have its magnetic type or any other physical sensor also can be placed. And also gripper, instead of gripper I have shown you this cylinder for this one, so because for simulating purpose, in real time it will be like this. So you will be having this is a single acting gripper, there is a double acting gripper as well. Okay, so this gripper can be placed in this place. So this is about the pneumatic circuit and functioning of this. Hope it is clear. If you have any doubts in the sequence or how to do the programming in the FluidSim software or anything, you can ask me in the comment box. And this FluidSim software is available for a demo purpose. It is free. It is available in the Festo online website. And in case if you are interested, you can purchase this software. It is also available. So if you are just a learner, then you can download it for free. It is demo version. All the features are available. Only thing is it will not stay for I think more than half an hour. So you have to finish your work within half an hour. And saving option also it's not available. But if you purchase the things, then you can save the circuit and you can redo later. All the features are available in the original version or the purchased version, licensed version. Hope it is clear, and in the next video we will discuss about how this electrical control circuit will be converted into PLC ladder logic, and the upper part is going to be the same one because this pneumatic circuit is actuators, so it is going to be the same one. And also I have not shown you here the conveyor part. Two conveyors are there, conveyor 1 and conveyor 2, which I have not shown here. In the electrical ladder, the PLC ladder, we will include that too as well, so that the total process you can see in a PLC ladder. And this function, that is pneumatics side, it is going to be same. Thank you for watching. If you have any doubts, please let me know. So watch part 2 for PLC programming. Thank you.